Okay, so talking about inheritance in C++, we'll talk about inheritance. The new section will be adding called the protected section, which is introduced because of inheritance. What effect this has on constructors and destructors. Then the fact that you can do multiple inheritance in C++, and then when you're multiply inheriting, you're getting functions and data from other classes, and you have the ability to overwrite those functions and data. Okay, so what is inheritance? Inheritance is when you create a class and you decide if it has functionality similar to another class, you can collect all of its data and functions that are defined in their public section. You don't get what's in their private section, you only get what's in their public section. So the way you would do that in C++ is by saying something like this. We could create a class called savings account, so that would be, let's say, a particular type of account, that a banking application. And then we say colon, that means we're inheriting from. You might be used to the word extends being here for Java and C#, but this is in C++, you just say colon. Then we're going to say this thing, I'll explain this in a second, what public inheritance means. And then I name the class that I'm inheriting from. So by doing this, I get the data and methods that are in the public section of the class account, which already exists from before. Somebody created that before us. Then I can add more data and more methods. Functions, sorry. C++ they're called functions, and in Java they're called methods. And I could add more on top of what I inherited. Okay, so really the only thing new is this colon, if you're used to seeing the word extends from another programming language. Okay, so C++ has the idea of public inheritance and private inheritance. So for example, with public inheritance, you can say class, savings account, public account, and then more stuff, just like the example we did last time. And the public elements of the account class get copied into the public area of the savings account class. And then you can add whatever you want into public and private after that. Private inheritance, this should be private. Sorry about that. Let me just change that right now. Okay. This should say, okay, so this is saying private, we're inheriting privately. What that then means is the public elements of account get moved into the private area of savings account. And then we could add additional public or private stuff on top of that. So this concept of inheriting publicly or privately, let me just go to a later slide, and I'll fill you in more in detail of that. Okay. So now the question is, so up until now we've had the idea of a public section and a private section. Now comes the idea of, suppose we want to have data that should be private, in other words, the outside of the class should not have access to it. However, we anticipate that someone may inherit from us, and we'd like them to be able to inherit that data too, but leave it private to the outside world. Well, with just the public and the private section, the only things we could do is either allow the private section to be inherited or not inherited. But sometimes we want the data in the private section to never be inherited by any class. So the idea, we would like to have a section that is kind of acts as private, but you can inherit it by derived classes. So a third protection area was added called protected. So protected data and functions can be inherited, but are still act as though they're private to the outside world. So a lot of people will say that the protected section is between the private and public. That it's private, but it's inheritable. Whereas the private section cannot be inherited and is not accessed outside the class. Okay. So now the idea is this. We just talked about we could inherit publicly and we can inherit privately. And we said that what will happen is this, if we inherit publicly, the stuff in the public section gets copied into the public section of the inheriting class. We said if it was inherited privately, then everything kind of took a demotion and became private. Do you think so? So now the idea is we have three areas: public, protected, and private. And it turns out we can inherit a third way. We can inherit protectedly. So you can inherit something protectedly. So now the thing is this. If you were designing this programming language, would you allow the access, which is public, protected, or private, of the inheriting class, would you ever allow it to have an upgrade or promotion to a more accessible section of the class? So for example, if there was a class that had a private data field, would you want there to be a class that could come along and inherit it and promote that private field into a public field?
Doesn't that defeat the purpose of a private field?
Well, yeah, so in other words, I don't want you to have to memorize this chart. I want you to just logically understand it so you won't have to memorize it. But so what's your explanation? That's pretty good. Why?
Well, it's private, like, why wouldn't you just make it public then, or protected?
Right, like let's say in that last example you had, like let's say we had a bank that had a general type of account, and then we started making specific accounts like savings accounts, checking accounts, you know, borrowing accounts or loans. So if we had a field called balance and it was private, would you want savings account to inherit it and then turn it into a public field?
No.
No, because that's protected, isn't it?
That's data relating to that one account. Isn't that balance for that one account?
Right, but you want to inherit, let's say there are things that all accounts have in common, for example, a balance field.
But their data's all different though, right?
Right, but would we ever want to be able to, if the designer of the base class wanted it to be private, would we want to allow the possibility of someone to come along, inherit from it, and then make it public?
No.
No.
And what's the logic behind that?
Because assuming the person who wrote the original class had, did it
right.
on purpose, did it
Right.
all right, he made it private for a reason.
Right, now you could just come along, inherit from it, and expose it to the world, right, under a different name.
Yeah.
So we would never want to be able to inherit and have anything go upward. We would never want something protected to become public. We'd never want something private to jump up to protected, which could then get inherited again. Because the designer wanted the private area to never be inherited. So we should never be able to go upward, but we could go downward, because all you're doing is making more protected. So we can take, if we inherited publicly, the public stuff becomes public. The protected stuff becomes protected, and the private stuff doesn't get inherited. If we inherit protectedly, the public stuff takes a demotion and goes down to protected. It's kind of like the way in which we inherit becomes the cap. So the public stuff gets inherited into the protected section. The protected stuff stays in the protected section, and the private stuff does not get inherited. The private stuff never gets inherited. And then if we inherit privately, the public stuff gets demoted down to private, the protected stuff gets demoted down to private, and the private stuff doesn't get inherited. We would never go upward, but we can go downward. And the designers of Java decided this is all like pointless. Why would you want to start moving stuff downward? So they just inherit. It just gets copied over section for section. So the idea that you could inherit and take the public stuff and turn it into protected stuff is not an option available to them. So this is more flexibility, and if you could think of a real-world example where you'd want to start inheriting other than publicly, that's worth 2 points if you could think of that. It's hard to come up with a real-world example where you'd want to do that. So going back to this example, what we're saying here is I want to create savings account, and I'm inheriting it publicly. And what this really means is The public data and methods from account get copied into the public section of savings account. The private, the protected fields get copied into the protected field, and the private ones don't get inherited. And if you do it privately, you're forcing demotions. Anything that is less restricted than private gets pushed into private, and everything else is the same. Okay, so the constructors and destructors are called in the order of base class, then derived class. Okay, the first line of the derived constructor must call the base class's constructor first. That has to, otherwise you'll have a compiler error. In Java, I believe if you don't say super, it does a super for you. Is that right? If you don't explicitly call the thing you're inheriting from's constructor, it will call it for you. Right? Okay. Here you have to explicitly call it. Okay. The derived class constructor always calls the constructor of the base class first to initialize the derived class's base class members. So again, you want to try not to have to memorize this stuff. It kind of makes sense that the fields you're inheriting should be initialized first because you're adding fields on top of those fields. And your fields or methods might assume those have been initialized already. Okay. And if the derived class constructor is omitted, the derived class default constructor will be added, and its first and only thing will be to call the base class's constructor. So if you remember, if we don't supply, constructors are optional. If you don't supply them, your storage gets filled in with default data. But if you inherit, then your constructor, the default constructor, will call the base class's constructor first and then fill in your data with default data. And then this is just an across-the-board rule in C++. Destructors are always called in reverse order of constructors. The objects are built and put on a stack, and when they get destroyed, the destructors run in reverse order. Okay, so let's just take a look at an example of a piece of code, and we'll just back this up slightly. Okay. So, little snippet, let's say we were to run this. If I was logged into the computer, we could run this and just see what the output is. But basically, we have a base class, we have a private section which has nothing in it. And actually, just a little side comment. By default, if you don't specify public, private, or protected, the default is private. So you could just start typing in stuff without saying private, and that stuff is automatically private. Then if you want to switch it, you have to type in something. So actually, there's really no need to ever type the word private, because you can type the private stuff first, and then if you decide to switch it to public or protected, and then you could also switch back. You could say private and start adding more private stuff here, but that kind of looks silly, so you try to put all the stuff in one section. Okay, so this is really a waste of a line, saying private and then doing nothing about it, and switching to public. Okay, so now we have a base class, and it has a piece of storage of type B, which is some class we don't see right here. And then we have a constructor and a destructor. Now we have a derived class, a class called derived class, inheriting publicly from base class. And the derived class has in its public section some object D, and then it also has its constructor and destructor. So if we were to create an object of type derived class, what constructors would run? And in what order? So we're making an object of type derived class. So the line would be like derived class space DC semicolon. We're now making one of these. So we go to constructed. What happens? Would the constructor start running right away? And what would a constructor do? It would start taking the data and filling it in with default data, but what is this thing? This is not a primitive type, it's something obviously someone made up. So would this thing get constructed first? And then once all the data is kind of set up, then we could run our derived class constructor to alter it? And so what would get, so what's happening? We're trying to create a derived class object. What's the first thing that happens? Constructor and destructor wise. Yeah?
Does it go to the base class and then go down? Because does it need to get those public variables? Like, let's say like derived class constructor is using a public variable from base class. Wouldn't it have to go to base class first, then derived class?
So it would go to the, yeah, let's try to do this without memorizing, like logically. So what you're saying is, we would before we do anything, we should realize we're deriving, we're inheriting from base class. So we should construct the base class object first before we start even initializing our own data. Okay. So that would mean, forget about what this comes later. Let's go up here and construct a base class object or storage first, and then construct the derived class. So when we go to construct the base class, what do we do first? Does this object B, I just kind of threw in here, would we create that first and then run this constructor? And this one apparently has a constructor too. Whether this class has one or not, it has a default one. So then you're saying this would run first. Now what would be created? Should the B's constructor run first, then our constructor runs on top of that so it can alter the B thing? Or should we write to the data of B and then have the B's constructor then run after us? So which one?
Second choice. You go to B's constructor, then the base class constructor.
We do B's constructor, then the base class constructor, then we know this object's done, now we can start to make this thing.
Yeah, because
And
if you don't do that, then don't you need some of those variables or some of that information?
Is B a class or a type def?
B is a
Like
class,
capital.
it's a class, but
Okay.
we're instantiating one. So a B's base class is composed of a B, whatever B is. Okay, so,
So wait, if you put some logic in the default constructor of the base class, and you create an instance of the derived class, that logic is executed?
if you put construction logic,
Like in other words, yeah, and that, you,
like when you make one of these, do the, get a pointer, grab some storage,
something,
point that,
yeah.
do something, right?
and you just call the derived class's constructor.
Right.
Will that execute the logic in the base class's constructor?
Well, the first thing this constructor should do is call the base. Before,
okay, that's
before
right.
anything gets constructed in the derived class, the base class
I
constructor
thought,
should.
I'm sorry, I thought you were saying that the base class got called and then the derived constructor got called. But you're saying the derived constructor calls the base constructor. Which makes
Well,
sense
it
to
should,
me.
okay, so wait. I mean, I don't think we have any other ideas, so I think this is what we're kind of going with. We're saying that before the derived constructor runs, the base constructor should run, so that the derived constructor can then, having that data being initialized, it gives us an opportunity to change whatever it did. So like, for example, last time we had a ratio which had a numerator and a denominator. The data got created first, initializing everything to a 0, and then our constructor can come along and say, no, I want the denominator to be a 1. So we want it to be first constructed, filled in with some default data or whatever it thinks its default should be, and then we have an opportunity to change that. Yeah?
Do you have to explicitly call the base class's constructor, or does it do that automatically?
That would do it automatically.
Okay.
So now, what ended up happening, before we could create the derived object, because we inherited from the base class constructor ran, but before that could even run, the data had to be created first before we could then start altering the data. So remember, like the idea of a constructor, and they're optional, it gives us an opportunity to change the default. So the constructor runs after the fields are created for us. So B's constructor would run first, then the base class would run, then we're back to D would have to be created before we could run our D class constructor, which could alter the D and alter the B, if we wanted to. And then what order do the destructors run when this object goes away? It's always the reverse of the constructors. So that's a popular, like, C++, you know, job interview question. Like, they'll give you some little snippet of code and say, what order will the destructors run in? And what you have to do is figure out what order do the constructors run in, and then reverse it. Okay. Okay, so then one thing we can do in C++, which other languages like Java and C# do not allow, we're allowed to inherit more than once. And in fact, just to make this is like one of the most complicated inheritance things, what they call a diamond design. We have, I know this didn't come out too good, but this says electronic device. So maybe this is a class that, let's say we were an electronics company and we were making electronics products. There might be some things that the electronics products all have in common, like they might have a serial number. So we might have a field up here called serial number, and that way every product we make will definitely have a serial number. And we say all our electronic products must inherit from electronic device. Then we start making a whole bunch of electronic products like clocks, radios, iPads, iPods, all kinds of electronic products. And let's say we have a clock and we have a radio. So the clock would get a serial number from inheriting from electronic device. So if the serial number was, let's say, an array of characters, well, maybe it's an array of integers if our serial numbers don't have letters in them. That field would be in the public section, and then the clock would pick up a serial number. Radios would also pick up a serial number, and every electronic device that we ever make would pick up anything that comes out of this electronics class. What we can do in C++ is, and this is kind of rare in the real world, where you would actually create a class that is a special type of a previous class. See, generally when you inherit, when one class inherits from another, the thing at the lower level is a more specific version of what's at the higher level, right? Like you might have seen examples where you have animal and then it's dog, cat, and bird and all that. So what you're inheriting from, you're saying, I want all those attributes, plus I'm going to add more stuff, which means I'm being more specific. So it's very rare that you would multiply inherit, because a clock radio is a specific type of clock. It's one that has a radio. And a clock radio is a specific type of radio. It's one that has a clock. So it's kind of rare that you have this hybrid thing, but there are examples in the real world, and this would be one of them.
What about people?
What's that?
Can't people be an example? You have like a person, like a mother and a father, and you have a child.
Well, but
Because you don't.
the child doesn't have all the attributes of a mother and all the attributes of a father. And you know, it's
Yeah.
there are real world. It's basically if you
No,
take.
but you might need to inherit something. If you have a father that's, like, if you have like a father that knows how to cook and a mother that knows how to sew, you might take both
And
the
you,
traits in the
if
child.
you get both traits.
Yeah, so you
Yeah.
need to inherit one from the one from the other.
Yeah, so these could be just a like a collection of skills. You know, like one can cook and one can do something else,
might
you know,
be like-
and you're collecting those
Like
skills.
maybe like in a video game or something, you're doing like a job tree. Like some games have like class systems. If
Right.
you might need a higher up class, you know what I mean? You might need to inherit certain skills or bonuses from a previous class. If it's
Okay.
a hybrid class from like a video game.
Yeah, I mean, I'm not
Like
saying
role playing or something.
I'm not saying there aren't real world. This is one like I think anyone can follow, but there are more complicated ones where you would want to do multiple inheritance, like the examples you're given. I'm not saying multiple inheritance is 100% bad idea, but the creators of Java and therefore C# decided there's some issues that come up with this, and they decided to remove this functionality. But and I'll throw a few questions up in a second, but anyway, the way you would do this in code is, you would say, class, clock, I just put a hyphen there, clock radio, inheriting, so that's the inherit symbol, publicly, it's kind of nice that Java got rid of that, you gotta keep saying how you're gonna inherit. Publicly, I'm inheriting from clock, and then publicly I'm inheriting from radio. And then I can add more clock radio stuff here. Okay, so with a declaration like this, and using that diamond thing we had before, where we're saying a clock really inherits from electronic device, and radio also inherits from electronic device, a couple of questions worth considering are this. How many copies of the base class will Of
electronics?
Of
The
electronics.
base class electronics? will-
Yeah, would the clock radio get? Should we get 2? Should we get 1? Or should it be the programmer who's creating the clock radio to choose 1 or 2? So it's kind of a design issue, right? Do we want, should clock radios have 2 serial numbers? No, they should only have 1, right?
Yeah.
But what if, I don't know if anyone can think of something off the top of your head, what if clocks needed some piece of storage in electronics for clock-related stuff that its constructor would fill in clock-specific stuff, and the radio would fill in radio-specific stuff, and you can't say, well, you're only allowed to have 1.
Like special parts maybe? Or just-
Yeah, for example, there might be a field, that's a good example. In the base class, we might have a field called special parts. And that gives an opportunity for the clock and the radio to fill in what special needs they have. Should we then say clock radios can only have 1 special part? No, maybe they need 2. But then do we want 2 serial numbers? No, maybe we need 1. So if you were designing the language, would you want to inherit 2 copies of the base class or 1, or would you want to give the programmer the ability to choose 2 or 1?
Programmer the ability.
Yeah.
Yeah, but so what's the downside? Obviously, giving more choices to the programmer is good, right? Because it lets the programmer have the flexibility. What's the downside to giving all these choices?
Bad programmer.
Well, bad programmers, plus if you pick up somebody else's code that they wrote 2 years ago, you gotta know, did they take 1 copy, did they take 2 copies?
Well,
But
shouldn't
they
that
just,
be within the code itself though? Shouldn't you be able to?
it would be in the code, but it's just more stuff for you to make sure you remember and
But you
maybe.
have the choice to do it, though. That's the thing.
Well, that's the thing, if you keep giving people more choices, there's more stuff they'll screw up, right? You get in the
All
car,
more stuff you have to keep track of, so.
right, if you're in a car with a steering wheel and a cigarette lighter and that's it, not too much is gonna go wrong, but if you got all these buttons and how to program the satellite radio and a lot of the stuff you don't know how to use. And you don't wanna have your code turning over to somebody who doesn't know all the buttons. So, it's a debatable thing. But anyway, they decided to let the programmer have the choice. Do you want 1 copy or 2 copies? Okay, here's another interesting question we could ask. Suppose the clock has a member called sound alarm, a member function, right? So let's say it's an alarm clock. And it sounds a buzzer for 1 minute. That's what its method does. And then the radio has a method called play, which takes as a parameter a radio station and a volume, so it could play 95.5 at volume 3, which will play, this method will play the radio. Can clock radio have a member function also with the same signature called sound alarm, but it's not the one it inherited from clock, which plays a buzzer. It would rather have a sound alarm which will play the radio.
It would be overriding the method.
You'd have to,
That would be effed up.
that's the part
Why?
But
No, you
have
would
to say
want,
virtually.
wait, hold on, you would want that, right? So a clock that's not a radio would have an alarm which just makes a buzzer. But once you create a clock radio, you might want the alarm to, instead of having a buzzer, to play the radio when the time.
I think I'd be very confused.
Oh, we should use-
While writing.
What?
Like, because
The radio
Oh,
clock.
wait, forget about the programming.
Oh,
You-
okay.
you-
I'll think about the program.
Okay, all right, but in the real world,
Yeah.
you would
No,
want
right.
the radio to,
Absolutely.
you would want the alarm to be able to play the radio.
Oh, really?
Yeah.
That's cool.
Okay, but the thing is this, can you see a scenario where we might want this? We're inheriting a method called play from the radio. We'll leave that one alone, that just plays the radio. But we inherited a method from clock called sound alarm, but we don't want that one anymore, we want a better one. Because now we have a radio component to it. We'd like to, instead of sounding a buzzer, we'd like to play the radio. So, but unfortunately we inherited a method called sound alarm. Can we just say, forget that one, I have a better one? And the better one will now call play from that inherited from radio. So we're, in other words, we inherited from clock, we inherited sound alarm. From radio we inherited play, and now we're going to write a new sound alarm which calls play radio. Well, it'd have to do all the logic, like to find out when to play the radio. Like it would have to look at the time of day and the time the alarm was set, and if they both match, then start playing the radio. It would have to have code like that, but would you want to be able to do this? Or is it too screwed up? Like you were saying?
Want to. That's good.
No, now that you explain it, I think it's very possible.
But then how would we, so within the class clock radio, we would have to be able to say, go to the radio's part of clock radio and call its play method. Well, actually, the third question is where we'd hit this one. Let me just, we still haven't fully answered this one, but let's look at this one. Suppose the clock and the radio both had a method with the same exact signature called PowerUp. Like it's a method that every time you plug a clock into the wall, it sets the time to 12 a.m. And the radio has a method called PowerUp. Like if you plug it in, it sets the radio station to some default station and a default volume. Now you've inherited from both of them. You now have two methods with the same exact name. Can the clock radio call PowerUp, and which one would it call? Would it take the one it got first from the clock? Would it take, how does it know which power, it got two power-ups in the multiple inheritance? If you can only inherit once, you'll only get one copy, because the class you're inheriting from should only have one copy. If it had two copies of the same function, it would have had a compiler error. So now, clock is fine, radio is fine, you inherited from both of them, but both of them gave you a method with the same exact name. How do we solve this? Yeah.
Programmer's choice. But you said before, if we want, like, you don't want two serial numbers, so the program would say, I only want one. For this, you would say the same thing, you only want one power up, right?
Okay.
Or would that not work because you're only powering up half of the device? Like, you only get the
Well,
power
okay,
of the clock, and the clock power might give them
that's a good
radio.
point. If we were, an example, so PowerUp ends up being a bad example, because what we would probably want to do is make a clock radio method called PowerUp, which calls the clock PowerUp and the radio PowerUp, because we probably want to power up both things. But let's just say in general, if we inherited two methods with the same exact name from each class we're inheriting from, this only happens if you multiply inherit. There's a chance this could happen. If you're designing the language, what would you do? Would you cause a compiler error? If you cause a compiler error, you're forcing the owner of the clock class or the radio class to make a change because you happen to want to inherit from both, and they might say, I'm not changing it.
Well, then the compiler always wins.
Okay.
It does.
No, I know. Definitely. The compiler always wins. That's a good expression.
It always wins.
All right. So, that's a good, yeah, that's a good bumper sticker. The compiler. Okay, but wait a minute. So how would you resolve this? So would you say if two classes have one method that is exactly the same, you cannot inherit from both of them? Compiler wins, or?
Yeah, and then you have to make them change the name, so it won't be like PowerUp.
Yeah, but you're not going to get the clock guy and the radio guy to change the name.
Oh, that's true.
But couldn't you overload the method within the inherited class? Or rewrite it
To
within the
call
inherited
the
class?
one you like?
Yeah, or to rewrite a new one with the same name, like clock radio power up.
Or, so what are some other choices? So that's kind of a good idea. What he's saying is, and if you, so that, well, if we did it your way, then the compiler would have to allow the multiple inheritance even though it has the same name, and it's counting on you to fix the problem. So what you're saying to do is create a method called PowerUp, and then maybe your PowerUp just calls the clock PowerUp, or maybe just the radio PowerUp, or maybe both. but you put one in. So would you make the compiler, how would you design the compiler? Would you say, I will only allow this multiple inheritance if you supply a new method with the same name to resolve the dispute? You know what I mean? Like
Why would you want to turn off your clock anyway?
Well, you might, maybe you don't want to turn off the clock, maybe you want to turn off the radio. You don't want the radio on while you're sleeping.
Or you might want to turn them both on, or, but just, like, right now, if we don't take any action in designing this language, we can't, if somebody created a clock radio and called PowerUp, you don't know which PowerUp to call. So we have to somehow resolve this, so.
So like Phil said, it's either overload or override. I think it's overload. Why don't you just
Override means same name, different function.
Alright, so you want
Oh,
to,
no, so.
No.
isn't overload?
No, it's override.
Overload.
No, it's override.
No, they just
Overload would be
override.
two methods in the same class with the same name, different parameters.
Right, different parameters, right. So it would be override.
Alright,
So
so
maybe
So
that's
you
it,
would-
maybe the methods are overloaded. Maybe they have different parameters or something in the base class that we could use.
No, but what if
No,
they're
but
coming in
the function-
exactly the
The
same?
prototype is identical.
Yeah, if this scenario could occur, it's, you know, it's, I don't know if it's a lightning strike situation, because some of these, you could have like startup and have, you know, common names. So it's possible we could inherit two methods with the same exact name. We don't want the compiler to say, this is not allowed, so you can't inherit from both of these. So we have to resolve it. And we do have the ability to say, I want to call the clock's power up, or I want to call the radio's power up, but I need to somehow say,
Well, what if we created like like we created a PowerUp 1 which called radio's method, and a PowerUp 2 that called clock's power method, and then when we wanted to power up the button, we wanted to power up the
You could
clock
call
radio,
one
we
and
called
two.
either or.
right, so you're putting a wrapper in the clock radio class that calls the two. Which, okay, so that would work too. But would you want to just have a compiler error at the point where you say clock radio dot power up, and then say I can't figure out this one? But if you say clock radio something like dot clock dot power up, then I know which one you're calling. So that would allow us to do the multiple inheritance. But if you ever started calling one, you have to say specifically where it came from. And then we could do a wrapper class. We could make a method called PowerUp which calls both of them, and then we'd have our own PowerUp. So there's a couple of solutions to it. So we want the compiler to allow this to go through, but we want to be mindful of the fact that this can happen. You're calling methods, and you might not even be keeping track of where they're coming from, and they may have multiple ones which you have to take into account.
I mean, I know this is for an exercise, but wouldn't like the designer sort of prevent that from happening?
The designer of which class?
Of, well,
The new
overall
one, or?
software design, like wouldn't they make sure that methods wouldn't have the same names unless there's a specific reason for it? Or does that not really matter?
No, like, I mean, we could have a method called like display serial number, and a clock would have one, and a radio would have one, and now someone inheriting from both is going to get two copies of the same. It's, you know, it's not. I'm not saying this is like lightning striking. It will happen more often. It doesn't happen too often, but we have to be ready for it because we're inheriting from two different places, and if they have something in common, especially if they have a common base class, they could. Actually, if they have a method in the base class, we'll get two copies of the method. If we choose, like I say, we're going to be able to choose whether we want to inherit from the joint base class, one copy or two. If we choose to inherit two copies, then we're definitely going to get two of everything. So we definitely hit this issue. Okay, so in this case, back to this question, we could say, we could write a new method called sound alarm, which is only for clock radios, but it calls the radio's play function. And so therefore we would be overriding the sound alarm that we inherited from the clock. We'd just be ignoring it. Okay. So it just opens up the door to things we have to take into consideration. Okay, so the order in which the objects are constructed is the order in which the objects are declared in the class definition. So for example, if we created, if we said, you know, integer x, float y, you know, and we had a list of objects that we are creating, they get created in the order of which they're listed in. Now, if you remember, we talked a few classes back about an initialization list, where you can have variables like a numerator and denominator, and in your class, we can say they're filled in with the default value. So what order would you, and I hope this is more of a logic question than a memorized question, if your variables are declared A, B, and C, but they're initialized C, B, and A, what order would they get constructed in? Is it the order they're listed in, or the order they get initialized in? That initializing thing was an optional thing we could do.
They were constructed in the order they're declared in, because they're constructed when you declare them, then they're re-edited once you initialize them.
Right. Right, that's the thing you want to remember, that the initialization comes after the storage is gotten. So there's a popular trick question, a C++ trick question, where you have like storage A, B, and C, and they get initialized C, B, and A. And A needed C, A is defined to get its value from C or something like that. So you think C got filled in and then A took its value from C, but it didn't. So that's, I'll give you an example, I'll mail out at that question.
Do you have like a whole, like, you have all these like job interview questions? Is there a way
Yeah,
you
yeah,
can
I've
compile
actually,
them?
yeah, I put a whole booklet together, so.
Oh, okay.
It's on burn too.
I'll mail it out.
Because that'd be like useful.
It's on burn too.
Okay.
That's just the answer for everything.
Go burn too.
Okay, and then.
That, and if that's not true, the compiler always wins.
Yeah, I like the compiler always wins. Okay, so, and then as far as inheritance goes, base class constructors will be called in the order, base class constructors are called in the order in which the inheritance is specified. So in that example, when we said we're inheriting from clock, then radio, clock would get constructed before the radio would get constructed. So it's the order in which they're listed. The order in which the base class constructors are specified in the derived class initialization list, again, will not affect the order of construction. Okay, so that was pretty much the topic of inheritance. And then the next thing we'll cover is polymorphism, which is where I think it's maybe a little, it's a little bit different than it is in Java or C#. But basically the scenario is this: if we had a reference, or now in C++ we can have a pointer, we could have an object star PCR, pointer to a clock radio, and it's pointing to a clock radio. We could use the pointer to start calling methods. And then if the type of the pointer and the type of the object being pointed at are a mismatch, like for example, if we had a pointer to an electronics, but it was pointing to a clock radio, could we still call functions like PowerUp? So would the compiler say, no, you can't do that because there's a type mismatch, or would we say, well, yeah, there's a type mismatch, but I'm going to allow it to go through? Kind of like when you take a floating point number and put it in an integer. Should the compiler say you can't do that, or say, all right, I think I know what you're doing, and let it pass? And if it lets it pass, that's good because it's flexible, but certain things might go wrong. So, so polymorphism, which we'll talk about in our next lecture class, is where the type of the object and the type of the thing referring to the object, whether in this case we could have a pointer or a reference, if they are of different types and the referring object is higher up in the inheritance, what are the things we can and can't do? And it turns out there are things we can do and things we can't do.